Welcome to this deep dive. And we're going to be looking at artificial intelligence,
Okay.
specifically how good it is at solving visual puzzles.
Interesting.
Those brain teasers, that need logic A and D. You need to be able to see.
Right.
You'd think AI would just be crushing these things.
You'd think so, yeah.
But today's deep dive is going to reveal it's not so simple.
Okay.
So we're going to be looking at the research paper called The Jumping Reasoning Curve. And they also have some code to go along with this.
Yeah.
And basically what they're looking at is how well AI models do on puzzles.
Okay.
Like Raven's progressive matrices.
I've heard of those.
But kind of with a cool twist.
Oh, interesting. What's the twist?
We'll get to the twist.
Okay. Right.
But first I want to say this research really kind of gets into how AI is progressing kind of beyond just the headlines.
Yeah, beyond the hype.
Yeah.
Clickbait stuff.
Exactly.
Get into the nuts and bolts.
Yeah, so we've got some star players in this research.
Okay.
We've got the GPT series from OpenAI.
Familiar with that one? Yeah.
You've probably heard of ChatGPT.
Of course.
That's powered by GPT.
Mm-hmm.
But we're also looking at OpenAI's new O series.
Oh, okay. The O series.
And they're designed to be reasoning champs.
Oh, so they built them differently than GPT.
Yeah.
So a different architecture.
Yeah. It should be interesting to see how it stacks up.
Right. How comparative.
Against the GPT models.
Yeah.
So to test these AI models, the researchers used two special data sets.
Okay.
Puzzle LVQA.
Puzzle LVQA.
And AlgoPuzzy LVQA.
AlgoPuzzle LVQA.
AlgoPuzzy LVQA.
Catchy names, right?
Yeah, very catchy.
So Puzzle LVQA, first one, that's all about abstract reasoning.
Abstract reasoning.
So think puzzles with shapes, colors, and numbers.
Okay.
Testing if the AI can, find the patterns, make connections.
Right, so not just seeing the images, but actually understanding the relationships
Yeah.
between them.
Is it deciphering the visual information?
Yeah, exactly.
Then we've got AlgoPuzzy LVQA.
Oh, yeah, that's a mouthful.
This one's like Buzzled Zeal LVQA on steroids.
Like, imagine visual Rubik's Cubes or like a game of checkers
Uh-huh.
where the AI has to strategize the best moves.
Oh, wow. So it's not just about recognizing patterns. It's like actual problem solving.
It's problem solving with a visual element.
Right.
That's AlgoPuzzy LVQA.
Got it.
And that's where this jumping reasoning curve comes in.
Okay. The jumping reasoning curve.
Figure 1 in the paper, it's like a scoreboard,
Uh-huh.
It shows you how each AI model gets better with each version.
Okay, like a progress chart?
Yeah, but here's the catch.
Okay, there's always a catch.
The O models, while they're showing this progress,
Yeah.
they come at a hefty price tag.
Oh, so there's a cost.
The O1 model,
Oh, one.
the brainiest of the bunch,
Okay.
needs 750 times more computing power than GPT-4o.
750 times. That's a lot.
Yeah, it's a lot.
So it makes you think, is all that brain power worth it if it's going to take, a supercomputer to solve a simple puzzle?
Well, and that's a good point,
So-
How do we balance the reasoning power with the practical resource constraints?
Yeah, we want to use these models the real world.
Yeah.
Got to find a way to make them efficient.
Right.
Exactly.
So what did they find?
Yeah. What were the results?
Well, first off, their IS improvement over time,
Okay, that's good.
especially going from the GPT models to the O models.
So the O models are better.
The O models are clearly designed for reasoning, and the results show that
So it's not just hype.
it's not just hype.
We're seeing tangible improvements
Yeah.
in how they're tackling these complex puzzles.
But here's where things take a turn.
Oh,
Even the mighty O1 model
okay.
struggles with some surprisingly simple visual puzzles.
Oh, wow, really?
Yeah, and it makes you think.
Yeah, what's going on there?
What is it about human vision and reasoning
Right.
that's still so hard to replicate in AI?
It's a good question.
Hmm.
Yeah, raises some interesting questions about what we might be missing
Yeah, what are we missing?
in our current approach to AI development. So what were some of the specifics there? What kind of puzzles did it struggle with?
Well, they found that the AI models in general
Uh-huh.
were good with colors and numbers.
Okay,
Like they could figure out the patterns, they could make deductions,
makes sense.
but throw in some shapes and sizes and things get a little wobbly.
Oh, so the visual element really trips them up.
Yeah, and figure 3 in the paper shows this visually, and it's pretty striking.
Oh, I'll have to check that out.
Yeah, it's like AI has selective vision,
Yeah, like it can see certain things clearly, but then other aspects are just blurry.
Exactly.
Fascinating.
And get this.
Yeah.
There's a huge difference in how AI performs on multiple choice versus open-ended questions.
That's interesting.
Think about it with multiple choice.
Yeah,
The answer's right there.
true.
So even if the AI's reasoning is off,
Yeah.
It can get lucky and pick the right one.
Right. It's like having the answer key, but not understanding the material. You
Exactly.
can still get the answer right.
But with open-ended questions, there's no safety net.
Right.
The AI has to come up with the answer on its own.
On its own.
And that's where its weaknesses really show.
Yeah, where the cracks start to show.
And one example that really stood out to me was the chain link puzzle,
The chain link puzzle.
which is in Figure 7.
Okay.
The AI got the answer right in the multiple choice version,
Uh-huh.
but its reasoning was totally wrong.
It just got lucky.
Yeah.
So it highlights that even when AI gets the right answer, it doesn't necessarily mean it understands the reasoning behind it.
Yeah, exactly.
It's like parroting back information without true comprehension.
Yes. And then there's the clock puzzle,
Clock puzzle.
Figure 6.
Okay.
And this one, the AI actually got the concept,
Okay.
but it misread the clock,
It misread the clock.
leading to a wrong answer.
So even something as basic as reading a clock can be a challenge for AI.
It seems that way, yeah.
Wow. It really highlights how critical visual perception is. You know, we take it for granted as humans, but for AI, it's a complex skill that's still under development.
Yeah, and to understand where the AI is tripping up,
Yeah.
the researchers did what they call a bottleneck analysis,
A bottleneck analysis.
which is basically like giving the AI hints to see where it gets stuck.
Okay, like troubleshooting.
Yeah, and guess what? Table 2 shows that the biggest hurdle for all the models,
All of them.
even O1,
Even O1.
is perception.
Perception.
Even the most basic visual details can throw them off.
That's surprising considering how good AI is getting at other visual tasks, like, image recognition.
Yeah, it is surprising.
Seems like we're still missing something fundamental in how AI sees the world.
It really does.
Like, it's almost like having a world-class musician who can't tell the difference between a piano and a guitar.
Yeah.
The potential is there, but something's off in their basic understanding of the tools.
Yeah, and the analysis also shows that GPT-4 Turbo and GPT-4o struggle with inductive reasoning.
Inductive reasoning.
Like when you have that aha moment, when you
Wow.
figure out a pattern, that's inductive reasoning.
Like those what comes next in the sequence puzzles.
Yeah, exactly.
You have to figure out the rule
You have to figure out the rule.
to get the answer.
And while O1 shows strong inductive reasoning,
Oh,
there's a catch.
another catch.
It can only do it when it sees the visuals correctly.
Oh, so it's like having a brilliant detective who keeps misreading the clues. All that brain power goes to waste if the initial observations are flawed.
Yeah.
That's a great analogy.
And to really drive this point home,
Okay.
the researchers showed a case study
A case study.
in Figure 9.
Figure 9.
And even with hints about the visuals, Andy, the pattern.
Wow, so they're giving it extra help,
Yeah.
and it still messes up.
O1 misinterprets numbers in a puzzle.
It can't even get the numbers right.
It really shows how nuanced these challenges are.
Yeah, it's not a simple fix.
So we've covered a lot of ground here,
We have.
but there's so much more to unpack.
There is.
We've established that AI, even the super advanced O series, has some unexpected limitations. Yeah.
Limitations.
When it comes to visual reasoning,
It's not a silver bullet.
but why should you care?
Yeah, why should we care about this?
What does all this puzzle solving have to do with the real world?
Right.
We'll explore that and more in part 2.
Looking forward to it. Welcome back.
All right, so we've seen that AI, even the advanced O series, has some surprising limits when it comes to visual reasoning.
Right.
But why should you care?
That's the key question, isn't it?
What's the relevance of all this puzzle solving to the real world?
Well, when we look at these findings in a broader context, we start to see potential implications for how we develop and use AI in the future.
Okay, so break it down for me.
Well, first, this research challenges the idea that bigger AI models are always better.
Okay.
The O1 model is powerful, but its massive computational cost is a big drawback.
It's like having a giant rocket to deliver a pizza.
Exactly. We need to think about efficiency if simple visual puzzles require so much computing power. How can we expect AI to handle the complexities of the real world without breaking the bank?
It's a valid point. It's like trying to run your house on a hamster wheel.
Yeah.
You might get some lights on,
Right.
but it's not going to power everything.
And beyond cost, the findings highlight the need for a more balanced approach to AI development. There's so much focus on complex language models.
Yeah.
But this research suggests we might be overlooking the fundamentals of how intelligence perceives the world.
It's like building a self-driving car with a supercomputer for a brain. but forgetting to give it working cameras?
Precisely.
The processing power is useless if it can't see what's around it.
If even basic perception is such a hurdle for AI, we need to invest more in research that explores how AI can learn to see and understand the world the way humans do.
Yeah. It's like teaching someone advanced calculus before they've learned basic arithmetic.
Right.
You need those foundational building blocks
Exactly.
before you can move on to more complex concepts.
And this shift in focus could have a ripple effect across various fields, from robotics to medicine.
Oh, wow.
Imagine robots that can navigate complex environments effortlessly, or AI systems that can accurately interpret medical images,
Uh-huh.
all because they have a deeper understanding of visual perception.
So it's not just about solving puzzles.
No.
It's about equipping AI with the tools to function effectively in the real world.
Exactly. This research also has implications for AI creativity and problem solving. If we can teach AI to perceive the world more effectively.
Yeah.
Imagine the possibilities for artistic expression, design innovation, and scientific discovery.
It's like unlocking a whole new level of potential for AI.
Right, instead of just crunching numbers or writing text, it could compose music design buildings or develop new scientific theories.
And let's not forget about human AI collaboration.
Yeah.
If we can bridge the gap between how humans and AI perceive the world, we can create more effective partnerships in various domains. Imagine doctors working alongside AI systems that can help them diagnose diseases more accurately, or architects collaborating with AI to design more sustainable buildings.
It's about leveraging the strengths of both humans and AI to achieve something greater than either could alone.
But with all these possibilities comes some, ethical considerations as well.
Of course, responsible AI development is crucial.
If AI systems become more adept at visual reasoning, we need to ensure they're used responsibly.
Absolutely. It's like giving someone a powerful tool without proper training. We need to be mindful of the potential consequences
Yeah.
and make sure AI is used for good.
So this brings us back to a fundamental question.
What's that?
What does it mean for AI to be intelligent? Are we just chasing benchmarks, or are we striving to create AI systems that can understand and interact with the world in a truly meaningful and beneficial way?
That's a question that deserves serious consideration as AI continues to evolve.
It does.
It's a reminder that we're still in the early stages of AI development.
Uh-huh.
And there's much more to learn as we push the boundaries of what's possible. We need to do so responsibly
Responsibly.
and with a commitment to using this technology for the betterment of humanity.
Okay, so we've explored the nuances of AI reasoning, uncovered some surprising limitations,
Yeah,
and pondered the implications for the future.
big questions.
But we're not done yet. In the final part, we'll connect these findings to some even bigger trends in AI
Okay,
and leave you with some food for thought.
sounds good.
That'll keep you thinking long after this episode ends. Stay tuned. Welcome back to the deep dive. We've been really digging into this AI reasoning thing,
Yeah.
exploring those strengths and those surprising weaknesses of these advanced AI models.
That's fascinating, isn't it?
Yeah, and we saw that even the mighty O1
Uh-huh.
can stumble
Wow.
on simple visual puzzles.
It really highlights that intelligence goes beyond just raw processing power.
Yeah.
It's about perception,
Uh-huh.
adapting to the world and making sense of it.
And speaking of a complex world,
Right.
let's zoom out for a second.
Okay.
This research isn't just a one-off.
No,
It's part of a bigger trend in AI.
a bigger trend.
Yeah,
Yeah.
like we're realizing we need to tackle this perception problem
Uh,
if we want to achieve truly human-like intelligence.
yeah, there's definitely a shift happening in the AI community.
Okay.
Moving away from simply making models bigger.
All right.
The focus is shifting towards models that are more robust, more adaptable,
Okay.
and grounded in real-world experience.
It's like realizing you've been training for a marathon on a treadmill, and now you have to actually run outside, dealing with hills and weather
You
and
got to handle the unexpected.
yeah.
Learn from your mistakes.
You can't just stop the treadmill.
No, you can't just hit the pause button
Right. You got to keep going.
and interact with the world in a more nuanced way.
And this is where things get interesting for everyone, not just AI researchers.
How so?
Well, this perception problem isn't just a technical challenge. It's philosophical,
It is philosophical.
It makes us think about the nature of intelligence itself.
Right, like what does it even mean?
Yeah, if we're struggling to teach machines to perceive the world the way we do,
Yeah.
What does that say about our own understanding of
Yes.
perception?
Maybe we don't know as much as we think we do
Maybe.
about how our own minds work.
It's like trying to explain how to ride a bike.
Yeah,
But you've been doing it so effortlessly for years,
right.
you've forgotten what's
Oh,
involved.
you can't even break it down into steps.
Yeah, and it's just so natural to you.
Exactly.
So this brings us to a final thought-provoking question.
Okay, shoot.
If even basic visual perception
Yeah.
is such a hurdle for AI,
Right.
what does this tell us about the limits of current AI?
Mm.
Are we focusing too much on complex language models
Mm-hmm.
and not enough on the fundamentals?
The fundamentals of
Well,
intelligence.
how intelligence interacts with the world.
It's a big question.
That's a question that goes way beyond computer science.
It does.
It touches on what it means to be human,
Yeah.
to experience the world through our senses
Mm-hmm.
and make sense of everything.
It's a question worth pondering
It is. It's worth thinking about it.
and exploring further.
So as you go about your day interacting with technology,
Okay.
taking in information, navigating the world,
Mm-hmm.
keep this question in mind.
I will.
How does your own perception shape your understanding?
That's a good one.
What are the limits of your own knowledge?
Yeah.
How can you push beyond those boundaries?
Interesting.
And maybe by thinking about these questions, we can gain a deeper appreciation
A deeper appreciation.
for both the amazing capabilities and the humbling limitations
Yes.
of artificial intelligence,
And our own minds.
as well as our own human minds.
Well said.
That's all for this deep dive.
That was a good one.
Thanks for joining us,
My pleasure.
and we'll see you next time.